All right, hello. So today we're going to learn about how to balance a redox equation. So usually the question will give you an equation and mention that or not mention that it's a redox equation, and usually it's not balanced. Your job is to balance the equation. Now let's look at this equation. Cobalt 3 plus, it's an aqueous, combines with nickel solid and produces cobalt 2 plus aqueous and nickel 2 plus aqueous. So if we were to draw a diagram of what's happening here. So CO3 plus is right now dissolved in a solution, and nickel solid is dropped inside here, right? And here it is, nickel solid, and it somehow reacts with cobalt. And then what does it become? Nickel 2 plus becomes an aqueous ion, basically. And we know this is a redox equation because we can look at the oxidation number and see how the oxidation number changes here. So let's look at the oxidation number. Cobalt would be 3 plus, nickel would be 0, cobalt 2 plus is 2 plus, nickel 2 plus is 2 plus. This one's pretty simple. Now let's see which one's being oxidized and which one's being reduced. Let's look at cobalt first. It starts with 3 plus and it becomes 2 plus. So it's becoming a little bit more negative, right? Or less positive. So since the charge is becoming more negative, it's being reduced, and it's going from 0 to 2 plus. This is becoming more positive, right? So that would be being nickel would be being oxidized. Okay, so in order to balance it, we gotta first write something called half reactions. So let's first look at the oxidation half reaction. So we know that nickel is being oxidized here, right? So we write nickel here. And remember, oxidation from oil rig, oxidation is loss of electrons, right? So because it lost electrons, it became more positive. So that makes sense. So on the left side, it's the charge is 0. On the right side is charge is 2 plus, right? To balance the charge, this means nickel lost 2 electrons. So during this reaction, nickel solid becomes a nickel 2 plus aqueous, and it lost 2 electrons in this process. So as it was becoming this, as the nickel solid is becoming an ion, somehow 2 electrons are being released in this process. So that's why it's being oxidized. Now let's look at a reduction half reaction. So let's see, cobalt is becoming cobalt 2 plus. And we know reduction is gaining electron, right? And it's pretty obvious here because it's going from 3 plus to 2 plus. So it became a little bit more negative. So since it gained electron, we write the electrons here. Gained an electron. So yes, so first you write the electrons like this. Next, we have to balance the number of electrons here. So since this has 2 electrons and only 1 electron here, we multiply this by 2. So the whole thing, we multiply the whole thing by 2. So it becomes 2 cobalt 3 plus 2 electrons equals 2 cobalt 2 plus. So that's this equation multiplied by 2. And then what you do is you just add these two equations The reactants add together, and the products also add together. So if you add these together, it would become nickel solid plus 2 cobalt electrons, and then nickel 2 plus 2 electrons plus 2 cobalt 2 plus, right? And after that, you eliminate the 2 electrons, and you're left with this equation. Now we can see that this one was pretty simple, right? We can see that what changed is that we added 2 on the cobalt here compared with the original equation, right? And the reason we had to do that is because that balances out the charge, basically. This side has total of plus 6, right? This side has 2 plus here and then 4 plus here. So the charge balances out in the end. So that's how you balance a simple redox equation.